Have you ever wanted to scrape data from a website but you didn't know where to start? How do you get static content? What about dynamic content that only appears after interaction? How do you scrape data rendered on the client side? And most importantly, how do you do all of this without getting blocked? And what are proxies and how do you choose the right one? Well, today I will answer all of these questions. We will start with standard web scraping using raw HTML and Cheerio. Then we will implement proxies to avoid blocks and IP bans. After that, we will level up with Puppeteer to scrape dynamic content, handling JavaScript loaded pages, delayed elements, and even user interactions like clicking buttons. And finally, I will show you how to scrape massive websites without ever getting blocked. Does this sound good? I hope so. Let's dive right into the video. So as you see right here, I have created a website, and this website will teach us everything there is about web scraping. So let's quickly look at the website, the code, and then I will first of all explain to you what web scraping is, and then we will implement it. So as you see, we first of all have a static section. This is relatively easy to scrape because we see the HTML, we see the content. Then we have a hidden section. This hidden section needs interaction. I need to click this button to see my secret information. Then we have delayed content, so we have a timing issue. If I click on the button, we have like a 2-second delay, and then we see our content. And then we have an interactive form, so I can provide my name, I can provide an email, and if I click on submit form, I get a little pop-up, and I can also scrape the content of this pop-up. So now let's look at the code. So here you see my index page. This is our page.tsx. We have our return statement, and then I have my first card. This is for my static content. I, for example, have an ID of static content section, and then we have our card content. In the card content, I have an UL with multiple LIs. One LI is one product. So the first LI houses my product one. I have span elements for all of my, you could say, details. So this means for product one, the name, for the price, for the category, and for the description. And each span also has a class name with the corresponding name. So product name, product price, product category, product description. And again, each LI is one product. So as you see, product 1, product 2, product 3. Then let's look at our hidden content. This is very interesting because our hidden content only shows content, I know, very funny, if the state is set to true. So we have a state which is show hidden content. This is set as false as a default value, so we don't show the content. But if the user clicks the button, we have an onClick handler, and we set our show hidden content to true. And then we have a ternary where we check, hey, if show hidden content is true, then let's render our content. And why is this interesting? Well, that's because we can't really parse the HTML. What I mean with that is if I open my inspector and go to the elements, there's no way to see content. And that's because we use client-side state. And then let's also quickly look at our delayed content section. So for this section, I have a function, load more content. We have a set timeout function with 1500 milliseconds. And then I just set my content, or in other words, I just update my state with my new content. So that's why we have this little delay. And for the interactive form, we just have a function which creates this little pop-up banner. That's all, relatively simple. So now we understand how our website works. Nevertheless, I haven't answered one fundamental question. What even is web scraping? So this is Wikipedia. And now let's imagine I want to get content from one specific article. So here, this is the article of the day. Bam, let me copy it. Wow, I just scraped a website. Now this is a very basic example. This won't work at scale. You can't just go to every website, copy the content and put it in your database. This takes too much time and it's not ergonomic. So what is if you could scrape a website programmatically? So this means an API, for example, which calls this website, scrapes the content, and then, for example, stores the content in your database in an Excel sheet or something like that. And why would you even use web scraping? This is a good question. I mean, we have APIs, right? But the thing is, not every website offers an API. Either they don't even have an API, or it's super expensive with a lot of limitations. So that's why most people use web scraping, and that's what we want to now implement. We want to create an API route which will scrape our website. We want to scrape the static content, the hidden content, the delayed content, and we want to also scrape the pop-up from our interactive form. So, are you ready? I hope so. Let's create our first API route. So, I already created a route handler, so I use Next.js, but every concept also works with Node.js. So, if you use Node.js, you can just continue. So, in my app folder, I created an API folder with a child folder which is called Scrape Basic. In the Scrape Basic folder, I have a route.ts file, and with that, I create a new route handler, or in other words, a new API route. Inside of here, I have an export async function, I expect a get request, and then I just return a new message which says hello world. So we can also, of course, open our API route. So let me start my dev server with pnpm1 dev, and then in my URL, I can navigate to /API/scrape basic. And what do we see inside of here? Let me zoom in a bit. Well, we see a message which says hello world. But right now we did not scrape anything, and that's not what we want to do. So let's fix it. So there are a lot of ways to scrape a website. There are easy ways, hard ways, good ways, bad ways. Just in general, there are a lot of ways to scrape a website. So let's first of all start with the most basic way of scraping a website. And that's to just get the HTML of the website. So we can just fetch the website, get the HTML, and then try to get our content. So let's try it out. Let's again go back to our API route. Let me delete the return next response, and let me first of all create a try catch statement. In the catch statement, I will for now just do a return next response.json, and I want to return a message of something went wrong, because sometimes your request can get blocked and you will get an error. So we will just return an error message. And later on, of course, I will also show you how to not get blocked. But now let's continue with our try statement. So first of all, we want to get our URL, which we want to fetch. So let's create a constant base URL, and this will be equal to my production URL. So I will copy it and then paste it inside of here. This URL, this website, is currently deployed at Vercel. If for some sort of reason this website goes down, then you can just go to my GitHub repository or to my YouTube description, get the GitHub repo link, download the repo, and host it yourself on Vercel, Netlify, Cloudflare, I don't care. There are no external environment variables or anything like that needed, so you can just deploy it easily. Nevertheless, I will try to leave this website online, but if for some sort of reason, again, it goes down, well, then it's very easy to self-host. But now let's continue. We have our base URL, and now I want to fetch my base URL or my website. So let's do a constant response, and then this will be equal to await fetch. Let's invoke it, and let's pass our base URL as an argument. Then we can do a constant HTML, and this will be equal to await response.text. So now we get our HTML from the website, and let's do a return next response.json, and I want to return my HTML. I want to see the HTML. So let's go back to our route handler. I will do a hard refresh, and wow, what the hell is that? Let's zoom out a bit. Where's my content? I see a lot of things, but I don't really see my content. Oh, right here maybe. Input, file, text. Yeah, quite annoying. So what we just did is we scraped our website. But instead of getting our product one name, our price, our category, we just got the whole HTML. And now we want to pretty much get details of our HTML. We want to get our static content. So to do that, we will use something which is called Cheerio. And Cheerio allows you to parse HTML and pretty much put it like into a DOM model. So it's way easier to work with it. It also has a very easy syntax, and it's actually quite similar to jQuery, but still it's a great library, and that's why we will use it. So you can click on tutorial, and then you can copy the installation command and install Cheerio, but I already did that, and now we want to first of all import Cheerio. So on top I can do an import. I want to import everything as Cheerio from Cheerio. Then let's go underneath our constant HTML, and now we want to first of all pretty much initialize Cheerio. So we can do a constant $. This is the normal syntax when you work with Cheerio, and this will be equal to Cheerio.load, and then as an argument we want to provide our HTML. So Cheerio will now take our HTML, it will parse our HTML, and it will create a structure which is very easy to manipulate. And what I mean with that is it will be very easy to get all of the content that we want. So the category, the name, stuff like that. And now we can continue since we are pretty much finished with initializing Cheerio. So let's first of all create a constant products. This will be equal to an empty array, and inside of here we will store all of our data. And now we want to get our content. How do you do that? Well, let's first of all again open our website. So to scrape a website, you would always open first of all the inspector, and you want to now first of all analyze the content. So we have our static content. Let's maybe go inside of here. What do we have inside of here? So we have a div element. Okay, in the div we have another div. Okay, this is for the header. This is not that interesting. But then we have another div with a data slot, card content. Okay, this is already a bit more interesting. In this div we have another UL. This is very interesting. Let me also zoom in a bit. So we have an UL with an ID of product list. And then we have an LI with a class name of product. We have a data product ID. Okay. And then in the LI, we have span elements. And each span has a class name, product price, product category. So the content is structured quite nicely. So we have a lot of selectors which we can use to get our content, and we will do that with Cheerio. So let's go back. Let's get our $sign. We have now already initialized Cheerio, and we want to now invoke it. So as an argument, I want to now pass my CSS selector. So in other words, what values do I want to get? So let's again go back. I want to get this UL. The UL has an ID of product list. This means as an argument, I can pass a string, of course, then a hashtag, and this will be product-list because that's the name of the ID. And just to make sure, you can also copy it and then paste it right here to not make any spelling mistakes. But now I want to also get all of my elements, all of my LI tags. All of my LI tags have a class name of product. So after this hashtag product list, I can add a dot of product, because when you work with IDs, you have hashtags, and when you work with class names, you have dots. So now we have all of our items, but our items are currently stored in an array. This means we want to pretty much map over our items. We want to iterate over them. So let's use the .each method. Then as an argument, we want to get the index and the element, and then I want to just open this as a function. Inside of here, I want to now get all of my elements. This means my product name, my price, my category, and description. Let's start with the product name. So let's do a constant name, and then this will be equal to our $sign. As an argument, we can pass our element, and then we want to use the .find method. Let's invoke it, and inside of here, I want to pass my class name. So right here we have our product name, product1, and this product1 has a class of product name. So I can copy it and pass it as an argument. So now we find an element with a class name of product name inside of our .product class. So inside of our LI. Let's append the .text method. And also quickly, we right here as an argument get an index and an element, right? So the index is the position of the item in the array, and the element is the current element, the current DOM element. So in this case, if I go back, the element is this span, this span, this span, and this p tag. These are all of our elements. And we also use the .text method right here because we want to extract the content from our span. Because if I wouldn't use the .text method, we would just get this whole span element. That's not what we want. We want to specifically get the content, and that's why we use the text method. Let's now continue. Let's do the same thing for our product price and product category. So I will copy paste it 2 more times. This will be our constant price, and we want to now find an element with the class product price. So let's copy it and let's paste it right here as an argument. We want to still use the .text method because again, I want to only get a text. Then our next element will be the category. So this will be in constant category. And then we want to find an element with the class name product category. Let's pass it again as an argument. And then the last thing we need is our description. So let's again copy paste it. This will be our constant description. We still want to find an element, but now with the class name of product description, let's again update our argument. And we want to also append after our text a .trim method. So this will just remove the white space from the start and from the end of our actual content from our description. And now this is finished, so now we can put all of our items into our products array. So underneath the constant description, I can do in products.push, let's invoke it, the structured, and then I can pass my name, my price, my category, and of course my description. And now let's test it out. So instead of returning our HTML, let's return our products. Let's save it, let's go back, let's do a hard refresh, and we have our products. We have in total 3 products. We have the name, the price, the category, and the description. And as you also see, the content corresponds to our actual content. So we have now officially scraped our first website, or in other words, our first content. But now we have one huge problem. Or let me correct myself, we actually have 2 huge problems which we have to fix. But let's first of all start with the first problem. So this diagram currently shows how we scrape our data. So this is our API route, which we just created right here. And this API route makes a request to, for example, Wikipedia to scrape the data. Now in this example, we have a static IP and we make about 10 requests per hour. Then we get our data from Wikipedia and we do something with our data. So we fetch data, we have a static IP, and we only make around 10 requests per hour. This is a relatively low threshold. In most cases, you make like 100 requests per second at scale. But scraping a website like this actually creates a huge problem. Let's look at the second diagram. Again, we have our static IP. We still scrape Wikipedia. But now, instead of doing only 10 requests per hour, we now make 10 requests per second. Or you know what? Let's update it to 100 requests per second. So Wikipedia will now see our request and it will see every request comes from one IP, from one static IP. And it will see, so a user makes 100 requests per second. This can't be a real user. This is probably a bot. So what will Wikipedia do? Well, Wikipedia will ban your IP. This means you won't be able to make any requests to Wikipedia from this IP anymore. So how can we prevent an IP ban? And not only an IP ban, also like captchas. There are a lot of problems which can come from static IPs. How can we prevent such problems? Well, we can use a proxy. So again, we still have the same setup. This is our API route. Our API route makes a request to Wikipedia. We still have 100 requests per second, but now instead of funneling the request directly to Wikipedia, we first of all have a layer which intercepts our request. And this layer is in proxy. And proxy is like, let's say it's like a big house with a lot of IPs inside of there. One IP in Germany, one in the US, one in Africa, one in India. And now your request will go through this proxy pool. It will get some sort of random IP, for example, in the US. And with this IP, you will now make a request to Wikipedia. And the nice thing is, even though you still make 100 requests per second, your IP rotates. Because instead of now only having one IP, for example, in the US, you now have for one request an IP in the US, then in Germany, then in India. You have hundreds of IPs, thousands of IPs, which rotate, which is super cool. And this prevents IP bans. So how can we implement in proxy? How can we prevent getting banned? Well, for that, we will use Smart Proxy. Smart Proxy is the sponsor of this video, and at the same time, Smart Proxy is the leader in proxy and web scraping solutions. But what does this mean for us? Well, Smart Proxy offers over 65 million ethically sourced IPs, which are located globally. And why is that important? Well, the more IPs we can use, the the better our web scraping results will be. So Smart Proxy offers a lot of different variations of proxy setups. You have residential proxies, static residential proxies, mobile proxies, and even data center proxies. But in this video, we will use residential proxies because in my humble opinion, they give the best results for standard web scraping. Nevertheless, if you would like to use a different proxy setup, like for example mobile proxies, then be my guest. But now let's look at one of the most important things, and that's performance. I have already scraped a lot of websites in my career, and with that, of course, I have also set up a lot of proxies. And one of the biggest problems was always slow performance. But thankfully, Smart Proxy has a great performance with a response time of under 0.5 seconds and an uptime of almost 100%. And if manual scraping with proxy setups isn't your thing, then they even offer web scraper APIs. They allow you to get large amounts of structured data from any website in just seconds with an easy-to-use API. And we can even test it out. Right here they have a little playground example, and we can scrape data from an Amazon search. So let's send this request. So we now scraped data from Amazon for the search query laptop. And as you see, the result is structured very nicely, which makes it very easy to work with. And since we are developers, documentation is super important. And thankfully, Smart Proxy has very detailed documentation, which will answer all of your questions. And now let's come to the best part. If you use the link in my YouTube description, you will get a completely free trial to test out both proxies and even the scraper API. And if you feel ready to get started with Smart Proxy, then you can use the code, which is displayed right now on the screen, to get 35% off on all plans. Wow. Oh, Smart Proxy even offers a 14-day money-back guarantee. And since you now know what Smart Proxy is, I think we can get started by implementing our own proxy setup. Okay, so I'm now in the Smart Proxy dashboard, and as you already see, I have a bit of traffic. That's because I already implemented a few proxies with Smart Proxy. You probably won't see anything, but that's fine. But now let's quickly look at the dashboard in more detail. So on the left side, we have our sidebar, and we have a section for our proxies and then for scraping. As mentioned, in this video, we will implement residential proxies. So let's click on residential, and then inside of here, you already see a bit of info. So this means right here, we have our username, and here you see my password. This is there to authenticate later on our proxy. And then in this gray bar, you see the location of your proxy setup. So right now for the location, I selected random. This means our proxy or our request could be proxied through India or through the US or any other country. But again, I can also select a specific country, like for example the US or Armenia or Azerbaijan, Australia, whatever. But in this case, I will select random because I want to proxy my request through any country, to be honest with you. And then we also have a session type selector. I have currently selected 10 minutes. This means for 10 minutes, I will have the same IP address before it again rotates. This, in my opinion, is a good default. If you want to, you can update it to 1 minute or 30 minutes or to always rotate, but I will leave it as the default, meaning 10 minutes. And that's already all. We have now already set up our first proxy, and now we can use it. So let's scroll a bit to the bottom. Right here, we already have like a little playground. Let's select Node.js, and then we already have our URL. So what we can do is we can copy this constant proxy agent equals to new HTTP proxy agent, and then as an argument, we currently pass this URL. Let's copy it. Let's go back. Let's go to our route.ts, and let's paste it underneath our base URL. And to make everything work, we also need two packages. So first of all, HTTPS proxy agent. This will allow us to first of all even create our proxy agent. And then we also need the node fetch package, and this will allow us to bind our proxy to our fetch call. And one thing which I mentioned quickly is that we are currently storing both our username and password in plain text. This is not very good for security, so this is not a security best practice. So instead, I would rather store them in my env file, so my Smart Proxy username and password. You can get your username right here. So for authentication, this is your username, and and your password is right here, which you can copy. Then once you have them, you can now update your username and password. So this is your username, as you see, the thing before your colon, and after your colon, you have your password. So since this is now finished, we can now actually bind our proxy agent to our fetch call. And as you also see, we already created our proxy agent using this HTTPS proxy agent package. And now let's go to our fetch call. Let's add a comma and let's open an object. Inside of here, I can pass an agent, and this will be equal to our proxy agent. So this means we will now funnel our request, first of all, to smart proxy. Smart proxy will give our request a new IP, and then using this IP, we will fetch our website, or we will scrape our website. We will then get our data returned, and we will have a nice day. So let's test it out. And if I again go back and do a hard refresh, I should still get all of my data. And yes, everything was successful. And of course, we can also go to Smart Proxy to the statistics. And inside of here, you see our total traffic. So we see the traffic and our requests. In total, I made already 5 requests. Very cool. And now let's try scraping our hidden content. So let's open again our inspector first of all. Let's go to our elements, and then what do we have right here? So we have this div, and then if I open the div, we have our content. That's not what I want. Okay, here we have card content. Let's see. Then we have our button. Where's my content? I don't have any content. That's because this section needs interaction. So if I click on the button, we now get our content. And this also means we now see it in our DOM. So I can open this div. This has an ID of hidden data. Then inside of the div, we have an UL. And this has an ID of hidden data list, and then we have an LI with a class name of hidden item, and then the actual value. So let's try scraping this hidden section. Let's go back to our codebase. Let's go underneath this product list extraction, if you want to call it like that, and let's create our hidden list extraction. So instead of just creating again a new array, constant products, and then pushing our data in the array, we can instead simplify it actually. So let's create a constant hidden data, and then this will be equal to our $. Let's invoke it, and I want to get an item which has an ID. So again, we have an UL, and this UL has an ID of hidden data list. So this means as an argument, let's pass an hashtag with hidden data list, because this is an ID, but we want to specify it. We want to get an LI with a class of hidden item. So let's also pass a dot hidden item. And now we want to map over our items because they are currently stored in an array. So let's do dot map as an argument. Let's get our index and our element, and then let's create an inline callback function. Let's again use our $. Let's invoke it as an argument. I want to pass my element. We want to get the text of our element because currently we only get the LI element with the class and then the value, but I want to only get my value. So let's use the dot text method, and let's also append the dot trim method to not get any white space at the start and end. And then after our dot map, so after these parentheses, we can also call or use the get method. This get method will retrieve all of our elements matched by the Cheerio object, but as an array. So now instead of creating a separate array and then doing our products.push, Cheerio will just do it for us, which is quite nice. And let's also now test it out if it actually worked. So for our next response, let me also pass my hidden data. And if I save it and do a hard refresh, we will see something interesting. Hidden data is an empty array. So we did not get any data. Why is that? Well, that's because, again, we need interaction. Our API route currently only gets the items which are right here. And that's, of course, a huge problem because our hidden content needs interaction. Our delayed content needs interaction. Our interactive form needs interaction. And currently, our fetch call only gets our static content, but we need dynamic content. So how do we fix this problem? Well, we will use something which is called Puppeteer. So Puppeteer is a JavaScript library which provides a high-level API to control Chrome or Firefox over the DevTools protocol or WebDriver BIDI. Puppeteer runs in the headless by default. This means no visible UI. So we will use Puppeteer to be able to interact with our website, because Puppeteer will now be able to click buttons, for example, wait for a few seconds and stuff like that. Fetch is relatively stupid. Fetch can't do that. But Puppeteer is an actual browser which can interact with your website. And now let's install Puppeteer. And right here you have two options. Please install the first one. This means Puppeteer Standard, not Puppeteer Core, because Puppeteer Core won't install Chrome. But we need Chrome, the browser, to interact with our website. So let's install Puppeteer. So I have now installed Puppeteer and now I can get started using it. So I have created a new API route, a new route handler called scrape-puppeteer. Inside of here, I again created an export async function. I expect a get request and I created a try, catch, and finally statement. So for the catch statement, I right now just return an error message, and for the try and finally statement, we currently don't do anything, but we will fix that together. So I want you to also open our old API route, because we will do a lot of copy pasting since we already created quite valuable code, which we can reuse in this route handler. First of all, let's copy our base URL. Let's paste it in our try statement. Now we want to initialize our browser. We want to initialize Puppeteer. So above our try statement, but still in our function, we can create a let browser. So we will use this variable to initialize our actual browser with Puppeteer. So underneath our constant base URL, let's do in browser, and this will be equal to await Puppeteer. Puppeteer is imported from Puppeteer.launch. Let's invoke it, let's destructure it, and here we have an headless property, and let's set it to false. This means our browser will open. So we won't just leave it headless, but we will actually have a browser window which will open and interact with our website. And also we currently get an error for our browser, but don't worry about it. It will fix itself in a second. So since we have now our browser, we want to open a new website. So we can do a constant page, and this will be equal to await browser.new page. Let's invoke it. So now we have our new page, but now we want to tell Puppeteer to navigate to our base URL. So let's do an await page.goto. Let's invoke it, and as an argument, let's pass our base URL. We can also add a comma, open an object, and add the wait until property, and let's set this to network idle 2. What does this mean? So network idle 2 just says, hey, Puppeteer, you should consider this website loaded when there are no more than 2 network connections actively running. So if there are more connections running, then our website is still not finished rendering or loading. And just to make sure that everything is loaded also on the client side, I will also add a timeout function of 2500 milliseconds. So with that, I want to just make sure that everything is initialized on the server side, but also on the client side. So now we can first of all get started by extracting our static content. So let's create a constant products, and this will be equal to await page.evaluate. Let's invoke it, and as an argument, we want to pass a standard arrow function. And now we want to first of all get our parent element. So let's go back to our example. So if I open my inspector and go to this actual static content section, we have this div with our cart content, and then I have my UL. My UL is the parent of my individual LI elements, so of all of my products. And for the UL, I have an ID of product list. This is nothing new. We also did the same thing in our scrape basic example. We first of all got our product list, and then we got our child. This means our LI element within a class of product. And I want to do the exact same thing inside of Puppeteer, so inside of our advanced example. So let's create a constant. This will be called product element, and this will be equal to document.query selector all, and then let's invoke it, and as an argument I want to pass my hashtag product list and .product. So let's copy it and let's paste it inside of here. So with that, we have now our product element, and this is an array. This means we want to now map over our product element. So let's do in return, let's get our array dot from, As an argument, I want to pass my product element. Then we can do a dot map. As an argument, I will get an element, and then I can just open the function. Inside of here, we can create a return statement. We want to return an object, and let's first of all get started with our name. So for our name, let's again go back. Right here we have our li. In the li, we have a span. This span houses our product name. And how can we get our product name? Well, again, we have a class of product name. So let's go back, and for the name, we can pass our element dot query selector, and we want to get our element using the class name, using product name. Let's copy it, let's do a dot, and let's paste our product name. Now again, this is text content. We don't want to get the whole span element, but we want to specifically only get the content. So let's append at the end and dot text content. Let's now do the same thing for our price, category, and description. So for the price, we have a class name of product price. Let's paste it right here. For the category, we have a class name of product category. I can copy it and paste it right here. And then we also have our description with a class of product description. So let's also paste it right here as an argument. Of course, let's also append for our description at the end our .trim method, just to make sure that we don't have any white space at the start and at the end. Okay, so now we have scraped our static content and now we can return it. So for my return statement, I can now pass my products. And now let's test it out. So let me update my URL. This will now be /API/scrape Puppeteer. And if I click on enter, you will see something interesting. A new tab opened within browser. This is the Puppeteer browser. And if I go back to my API route and do a pretty print, you see all of our items, our products, and for each product, we again have our name, price, category, and description. Wow, this worked very nicely. So let's again recap everything. We right here implemented Puppeteer. Puppeteer creates a new browser. This browser interacts with our website. We then scrape our content, and as you see, this code is very similar to our basic scraping route. So to our previous example, it's almost the same. We now just use the query selector method instead of the find method. But besides that, it's the same. We then return our products, and then we get them right here. Wow, so easy. But now we have two problems again. No, why? But okay, let's fix them. So let's start with the first problem. So right here in our route handler, we start our browser using Puppeteer. That's nice. But we never close it. And what's the problem if you don't close a browser? Well, you will probably run into a memory leak at some point. This means in the try statement, we want to start our browser, we want to launch it, but in our finally statement, we want to close our browser. So let's create an if statement and let's say, hey, if we have a browser, if this is true, then let's do an await browser.close and let's invoke it. So now we prevent memory leaks, and once our whole, you could say, extraction is finished, our browser will just close, it will terminate. But we have a second problem, and that's again our IP ban. So currently we scrape our website using our own static IP. And the problem with that is, again, we can run into IP bans, captcha problems, geo restrictions, and much more. So to prevent that, we want to again use a proxy, or in other words, we want to again use our residential proxy, which we already created using smart proxy. We will leave everything the same, so let's still leave the location at random, and also we will leave the session type as sticky, 10 minutes, I think that's fine. So let's go back to Puppeteer and let's implement it. How do you add a proxy in Puppeteer? This is a very good question, and it's actually not that simple as you would think. So let's open our old example and let's copy our proxy agent. Let's paste it underneath our base URL, and let's also delete this HTTPS proxy agent. We don't need it anymore. We just want to get our URL. And inside of here, we now have our HTTPS, we have our username, password, and then we have this @gate smartproxy.com with the port, which in my case is 7000, but in your case it could also be 1000 or something like that. So let me copy this gate.smartproxy.com with the port. Please don't copy the and delete everything that was in front of it. So our new proxy agent URL will be https:// and then gate.smartproxy.com and then your port. And now we want to pass this proxy to Puppeteer. So underneath our headless true property, we can add an arguments property. This is an array. Inside of the array, we can use upticks. Then let's pass in proxy server, and then this will be equal to a dynamic value of proxy agent. So now we have passed our proxy to Puppeteer. Nevertheless, there's currently one problem. When you use proxies with Smart Proxy, you have to authenticate yourself with the username and password. So how do you add a username and password right here? Because there's no property like username. Good question. Well, thankfully, it's quite simple. We want to go underneath our constant page await browser.new page, and we want to authenticate ourselves. So we can do an await page.authenticate. Let's invoke it, let's destructure it, and we want to pass in username and we want to pass in password. So for the username, let me copy the environment variable name, and then this will be equal to process.env.smartproxy username. Let's do the same thing for the password. I will copy the name and then again process.env.smartproxy password. So now this in theory should work. So let's go back. I will do a hard refresh, and as you see, I got my data. Again, I have all of my products, and then if I also go back to Smart Proxy, I now see my traffic. So in total about 800 kilobytes, and for the requests I have in total 26. So this works exactly as expected. We now proxy our request, we make sure that our IP does not get banned, and just in general we now follow best practices. But now we are still not finished, because we are now missing our hidden content, delayed content and stuff like that. So let's finish off this example. Let's go back to our route handler, let's go underneath our constant products, and now I want to first of all get my delayed content, because let's go back. If I do a hard refresh, we have the delayed content, and it takes about 1 to 2 seconds to get our delayed content. And after that, if I click on the load more content button, it again takes about 1 to 2 seconds to get additional data. So I want to first of all now get the initial loaded data, so the initial delayed content. So let's go back, and then inside of here we can create a constant. This will be called delayed content, and this will be equal to await page.evaluate. Let's invoke it. Then let's create an arrow function. Inside of here, let's do a constant items, and then this will be equal to document.querySelector all. And inside of here, we want to now get our delayed items. So let's again open the inspector. If I go into this section, you will see we have a div with our cart content. This is not interesting. In the div, we have another div, and this div has an ID of delayed content. And if I expand this div, we have an UL, and then in the UL we have an LI with a class name of delayed item. And now this ID, delayed content, and also the class name delayed item will help us to extract the content. So let's go back, and I want you now first of all get our ID, and this was delayed content. So let's copy it and paste it. So hashtag delayed content, and then I want you also get my class name delayed item. So let's copy it and paste it, and in front of that we want to have a dot. So hashtag delayed content and dot delayed item. So now we get our items, but as you know, we want to map over our items, because we don't only have one item, but we have multiple items. This means we want to map over all of them. So let's do a return. Let's again get our array dot from as an argument. Let's pass our items, and let's do a dot map. Let's get an item, let's return it, and I want to return my item dot text content, because I want to again get my content. Let's also use the trim method. So let's append dot trim and let's invoke it. So now this is finished, and let's also return our delayed content. So after our products, I can pass my delayed content, and let's test it out. So I again opened my route handler, and inside of here we again first of all see our products, and then we see our delayed content. Of course, right now we don't show the additional content, so currently we still don't really interact with the website. Nevertheless, we now have the ability to get data which is loaded on the client side, which is very cool because again, we didn't have this ability with our standard fetch call. But since we use Puppeteer within real browser and where we also can add delays, we can wait for the data to be loaded on the client side. So as a next step, I want to now first of all get my hidden data, and then once we have our hidden data, I want to also create the interaction with our delayed content to get the additional data. So let's continue first of all with the hidden content. Let's again open our inspector, and as you all know, we first of all have to click the button to get our content. So what we need is first of all the ID of this button. So let's see, we have a button, it has a data slot and a class. Okay, right here we have an ID. This helps us quite a lot. This ID is custom to this button, reveal button. So we can now tell Puppeteer to click this button and reveal our secret information. So let me copy the ID, reveal button. Let's go back. I will go underneath my delayed content and I want you now first of all click the button. So we can do an await and this will be page.click. Let's invoke it, and as an argument I have to pass the selector, the ID of the element which I want to click. In this case, this was our hashtag reveal button because this is an ID. Let's now continue. So Puppeteer in theory should have now opened, or in other words clicked on the button, and with that it should have revealed our secret information. So let's get our secret information. Let's create a constant hidden data or content, and this will be equal to await page.evaluate. Let's again invoke it as an argument. Let's create an arrow function, and inside of here let's again first of all get our items. So constant items, and this will be equal to document.querySelectorAll. Now we already selected our items in our old example, if you can remember. So let's scroll a bit to the bottom. Right here we had our hidden data, and we got our hidden data using the ID and class. Now if you already forgot that, don't worry, let's look at it again. So I can again inspect our elements, and inside of here we first of all have our h3. This is not interesting, but we also have this UL with an ID of hidden data list. But we want to get our LIs. So for the LI, we have a class name of hidden item. So let's first of all copy the ID. This will be the parent element. So let's go to our advanced example. Let's pass in hashtag hidden data list. And then we want to also specifically pass our child. So the LI. This has the class name of hidden item. So let's copy it, and as an argument, let's pass dot hidden item. So now we have our items, and again, we want to now map over them. So let's do an return uppercase array dot from. Let's pass items as an argument, and then let's map over our data. So let's use the dot map method as an argument. I want to get an item, and then I can return it, and I want to return my item dot text content, and let's use the trim method at the end. So now this should be finished. Let's again add our hidden data to our return statement. So hidden content, and if I again do a hard refresh, I should get my hidden content. So if I do a pretty print, we see hidden content, secret data point 1, secret data point 2, and 3. So this was successful, and that's super cool. But now let's also again continue with our delayed content. So now we are finished with our static content. We are finished with our hidden content. We get all of the data. We interact with the website, which is super important. But now we have to also interact with our delayed content because we get the initial data, but not the data which needs interaction. So let's again go back. Let's go underneath our constant hidden content, and let's get our data. So the workflow will be the same. We have to again click a button. We have this button, load more content, and Puppeteer should now go to this website, click the button, and then extract the content. So let's get the ID of this button. Let me inspect this element. So we again have a class, data slot. Okay, this is not custom. And here we have our ID. It has an ID of load more button. So let's copy it. Let's again go back and let's do an await page.click. Let's invoke it. And as an argument, let's pass in hashtag load more button. So Puppeteer should now in theory have clicked the button, and now we want to extract our data. But this is a bit interesting because again, if you go back, let me do a hard refresh to reset it, and if I click this button, we have a 1 to 2 second delay. So we can't instantly extract our data, but we have to wait for the network request. So how can we know that the data fetching is finished? Well, it's quite simple. If I click on this button is disabled while loading our data. So we can create like an if check, an if statement, and we can check, hey, if the button is not disabled anymore, then our data has probably loaded. So let's again go back and let's do an await page.waitFor function. Let's invoke it as an argument. Let's pass an inline callback function. And then I want to create my if check. And I want to say, hey, if our document.querySelector, and I want to again get my load more button. So let me copy this ID and let's paste it as an argument. If this does not have anymore the attribute disabled, then this means that our button, or in other words, our data has probably loaded. Okay, this is maybe a bit confusing. Let me again break it down. So this function, this Puppeteer call, goes to our button and it checks, hey, if our load more button does not have the attribute disabled anymore, and we do that with this exclamation mark, then this means that our data has loaded and we can now extract our data. So let's extract the data. Let's go underneath our await page, and maybe before I extract the data, I will also again create a timeout function, and as an argument, I will pass 500 milliseconds. I want to just make sure that the data has actually loaded, because sometimes there could still be some problems, so I want to just make sure. And now we can get our data. Let's create a constant, and this will be called updated delayed content, and this will be equal to await page.evaluate. Let's invoke it as an argument. I want to pass an arrow function, and now we want to first of all get our items. How do we get our items? Well, we already did it 3 times. So constant items equals to document.querySelector what? All, of course. Let's invoke it, and as an argument we want to again pass our ID and class name, because we again have an UL with an LI. You will first of all see an UL. This UL does not have any ID, okay, but the parent of the UL has a div of delayed content, okay, so we can use that, and then we have an LI with a class name of delayed item, so we can also use that. So let's again go back. First of all, let's pass our ID of delayed content. I will copy it and paste it. Of course, let's not forget the hashtag at the start. And then let's also add our class name, and this is delayed item. Let's copy it and paste it. Of course, don't forget the dot at the start. So now we have our items. Let's now again first of all convert them to a standard JavaScript array, and then let's map over them. So let's create a return statement. Let's use our array method .from as an argument. Let's pass our items, and then let's use the .map method as an argument. Let's get our item, let's return it, and I want to return my item.textContent.trim. And now this should be finished. Let's add our updated delayed content to our return statement, and if I do a hard refresh, I should get my data. Okay, this already looks quite nice. Hidden content, updated delayed content. Wow, this was so cool. Okay, and now there's only one more section missing, and that's our interactive form. So if I fill out this form and submit this form, we get a little pop-up, and I want to now scrape the info from this pop-up. So how can we do that? Well, we want to first of all fill out the form, and then we can use Puppeteer to get the data. So for that, let's go underneath our updated delayed content, and we want to first of all fill out and submit our form. So let's do an await page.type. Let's invoke it, and now we want to start with our first input. This is our name, or the input is for our name. So how can we fill out an input? Well, using an ID, for example. Let's inspect the element. Here we have an input with a data slot, class, okay, this is not unique, but here we have an ID of name. So we can use the ID to fill out our input. And now for the type, we can pass our hashtag, name, this is our ID, and then we want to pass our data. So we can add a comma, and then as the next string, we can pass our text. So demo input. This is now for our name, but we also have our email. So let's again inspect the element. So we again have our input. So here we have this ID, and the ID is email. So let's go back and let's do the same thing. Await page.type. Let's invoke it, again hashtag email, and as the second argument, let's just pass some sort of random email. Alright, nice. So now we filled out our form, but right now we did not submit it, but we will do that in a second. Now I want to first of all set up a function which will read our message, so from the pop-up, and save it in a variable. So let's create a let alert message, and then this will be equal to an empty string, because right now we haven't scraped the message. We will now use a Puppeteer function, which is page.on, and then we want to listen for the pop-up. So again, if I submit the form, we have this pop-up. What is a different word for a pop-up? Well, a different word is dialog. This means we want to now listen for a dialog. So as an argument, I will pass my dialog, and then as a second argument, I want to pass my function. So this will be an asynchronous function. As in param, I can get a dialog, and then this is a normal arrow function. And inside of here, we will now get our alert message. Now, if this currently confuses you, don't worry about it. Once we are finished with this code, I will explain everything again step by step. So let's get our alert message. This is our let variable, and our alert message will now be equal to our dialog.message. And then as last step, let's also do an await dialog.accept. Okay, I know you're now confused, so we just wrote a bit of code, but if you think through this code, you will probably see that it does not make that much sense. So what I mean with that is, right here we fill out our form. So we pass a name and we pass an email, but we never submit our form. And then right here, we start listening for an alert, or in other words, we start listening for a message, but again, we never submitted the form. So how does this work? So this is what you call an event listener. So it will listen for a dialog. So when we have a new dialog pop up, it will see that and then fire this function. As in param, we get a dialog event, we get a message from our dialog, from our pop-up, and then we do an await dialog.accept. This accept is pretty much just clicking this OK button. So yeah, we accept the pop-up, we click on OK. But as mentioned, again, this is only an event listener. It only runs when we actually get a pop-up. So to get a pop-up, we want to first of all submit our form. And for that, let's go underneath this page on, and let's do an await page.click. And now we want to click our submit button. Let's inspect our element. Right here we have our submit button. Okay, data slot class. Aha, we have an ID. Submit form. So let's copy the ID, and as an argument, let's pass an hashtag submit form. So this will now submit our form. It will generate this pop-up. This function will run, get the message, and accept the dialog. Nice. And just as a safety measure, let's also again create a timeout function down below of, let's say, 500 milliseconds, just to make sure that everything works correctly. And now we can return our message. So I can copy my alert message, and then right here in my next response, I will pass my message. And now I can test it out. So if I go back and do a hard refresh, I should get all of my data. I see a lot of data. Yes. Okay, let's pretty print it, and yes, we got our alert message. Form submitted. In a real scraping scenario, Puppeteer would handle this interaction. Very nice. And you know what? Let's maybe again check out our browser. So I will set the headless property to false again. Let's go back, and if I do a hard refresh, my browser opens. Let's scroll a bit to the bottom. This browser or Puppeteer should click on this button. It has done that also here. Now it filled out the form, we got a pop-up, and we are finished. So this was the live example of Puppeteer interacting with our website. But again, in a real world example, you set headless to true because you don't need the browser. And yeah, we have now implemented web scraping. We scraped static content, we scraped hidden content, which needs interaction. We scraped delayed content, which also needs interaction. And we even submitted in form and then scraped the data from the pop-up. Wow. Okay, so we are almost finished with this video. Nevertheless, I want to now also look at the web scraper API provided by Smart Proxy. So first of all, why is the web scraper API even interesting? I mean, we just looked at Puppeteer, and as you saw, Puppeteer is super powerful. And that's correct. Nevertheless, scraping a website like for example Amazon or Google or even Reddit can be quite hard, even with the best proxies and the best setup. There are a lot of, let's say, security measures that these big and huge companies have implemented. So the web scraper API allows you to get large amounts of structured data from any website in seconds using their web scraping tool. So at the end of the day, Smart Proxy offers one API with which you can get nicely structured JSON data. You can either use the already existing templates, like for example for Amazon or for Reddit or for TikTok, or of course you could use their standard web API and then scrape any website, like for example the ip.smartproxy.com website. And again, where's the benefit with the web scraper API? Well, at the end of the day, first of all, you have a 100% success rate. If you have your own setup, there are a lot of things which you have to manage. Retries, captures, blocks. The web scraper API is an unified product which does it for you. So again, you just call an API and you are pretty much finished, and all the hard work will be done by Smart Proxy. So as you see, with the scraper API, you will get proxy management, a pre-built scraper, and anti-bot bypassing right out of the box. And if you use the advanced tool, you even get JavaScript rendering. But you know what? Let's actually implement the web scraper API and let's maybe scrape Reddit, or to be specific, let's scrape a Reddit post. So if you go to the YouTube description and click on the link, you will again get redirected to this website and you will be eligible for a free trial. So definitely do it. But let me again log in into the dashboard. So I'm now again in the Smart Proxy dashboard. As you see, damn, we already had quite some traffic. But let's go to the scraping section and let's go to the API playground. Let's play with the API. Wow. So for the target, let's for example select Reddit. So I want to get a Reddit post. So let's select this playground. And then as an argument, we have to pass the URL, which we want to scrape. So here I have already found quite a funny Reddit post. So I want to scrape this post. I want to get the title. I want to get the image. And I also want to get all of the comments. And again, Reddit is a website which is as you all know, it's very big. A lot of people use it and they have a lot of security measures. They also have an API, but this API is super expensive, so it makes a lot of sense to scrape Reddit. And again, you can do it yourself with Puppeteer, it works, but the chance of getting blocked is quite high. So I will copy this URL, let me paste it right here, and you can also select a language and location, but I will leave it empty right now. And then let's send the request and let's see what we will get in response. Okay, so we got a response. So we got actually a JSON response. And as I already mentioned at the start, the nice thing is Smart Proxy gives you a very structured response. So I first of all get all of the core info about the post itself. This means the title, the image, you for example see the author full name and everything like that. That's quite cool. But if you also scroll a bit to the bottom, you will see the individual comments. So for example, let's go again to the post. One comment is, "Good God, we're gonna see a whole new generation of soon enough." Let's copy the comment message and let's paste it inside of here. Oh, what do we have? We have this comment in our JSON response. So we have the body, we see, hey, edited is false. So we get even more information than just the standard comment. We see again the author full name. We see, hey, this author never won any awards. Ah, man. I'm sorry for him, but okay. And we even get the body HTML. But you know what? Let's implement it in our own API route. So if you again go back to the request tab, you of course can copy the Node.js code. So let's copy this Node.js code. Let's again go back. I already created a new vault handler, Reddit scraper, and let me paste the code in the try statement. So we have a new constant response. We pass our URL as an argument. So this is the scraper API. This is a method of post. And then for my body, I pass my target. And for the URL, I pass the actual post. So the post from the web dev Reddit or subreddit. Now I want to of course also console log my data. So let's first of all await our response. And then let's soon return next response.json. And I want to pass my data. Let's again go back and then I will call my vault handler. And as you see, we got an error, failed, authorization header is required. Oh no, my header is empty. Wow. So let's again go back to the dashboard. Let's go to the web advanced section. So this is my actual scraper. And then inside of here, I can copy my authorization password. Let's paste it inside of here. Let's go back. And then I can again do a hard refresh. What did we just get? Well, that's the result of our web scraper. So the API, the Smart Proxy Web Scraper API, just went to this Reddit post, got all of the data, and again returned it. And in theory, I could now do whatever I want to do with this data. I could store it in my database, I could create an Excel sheet, store the data inside of there, and all of that without even touching Puppeteer or without even structuring all of the data. Oh, and of course, the documentation is also very detailed and we can even add a few more arguments to our query. So currently we just have our default query. This means we have our target and the URL. But I could also, for example, add the locale. So this is the language and then also the geolocation. Right now, everything is just the default, but we could, for example, say, hey, the geolocation should be the US, and then for the locale, I don't know, maybe German. And as you see, Smart Proxy, of course, offers a lot of pre-made templates, even for Amazon, Target, Walmart, but of course, a very general web scraper where you can scrape your own website. And yeah, I think we're now finished with this video. Let's again recap everything. We first of all looked at standard web scraping with our fetch call. We got HTML, we passed HTML with Cheerio, and we even proxied our request with Smart Proxy, eliminating any IP bans. And as you saw, proxying our request was also super simple. Then we had the problem with dynamic content. So we implemented Puppeteer, which creates an actual browser which interacts with our website. With Puppeteer, we were able to scrape dynamic data, data which has a delay, data which needs interaction, and much more. And then at the end, we also looked at the web scraper API provided by Smart Proxy, which pretty much unifies everything that we learned today by just calling an API vault. It's way easier, it's way faster, and you could even say it has a better success rate than doing it manually. Nevertheless, I hope you enjoyed this video. I hope you could learn a lot. I mean, we looked at a lot, to be quite honest with you. And yeah, please don't forget to like and subscribe. It would mean a lot to me. Thank you, Smart Proxy, for making this video possible. It took a lot of time to create this video because, hey, let me be honest with you, it's right now 11 p.m. So yeah, please don't forget to like and subscribe. Enjoy your day. See you in the next video. Bye.